Hello. So right now I want to discuss how to find the structure of HIO4. So first thing I like to do, this is how I like to do it. So first thing you want to do in general is to find out what the central element, so what the central atom is, right? So in order to find this out, we're going to look for whatever is least electronegative. We're not going to be talking about hydrogen. So it's either going to be iodine or oxygen, right? These are the two we're choosing between. And we know oxygen is more electronegative because if we looked at the P block, oxygen is all the way up here and iodine is here, right? This is the P block. So our central atom will be iodine. Start drawing that. We have iodine in the middle, and then oxygens all around. And hydrogen will be attaching itself to the most electronegative atom, right? A lot of Lewis structures based on electronegativity. So the hydrogen will be connecting to the oxygen. So let's put that down here. And now we have to find out how many valence electrons there are in total, right? So there's 1, there's 7, and then there's 4 times 6. So we have in total 32 valence electrons. What I like to do next is just put all of the valence electrons onto my Lewis structure. So we want every single thing to have an octet, right? Except we know that the middle atom doesn't need an octet. The middle atom can have more than an octet, or if it's boron, it can have less than an octet. And hydrogen, of course, just wants a duet because it's hydrogen. She's special. And now we have a Lewis structure, right? This technically works because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 32 valence electrons, right? But now we have to try to find out, if you are not up to the point where we have to find out, what's it called? Sorry, I'm blanking on the wording. If you're not up to the point where you need to find out their, what's it called? Formal charges. Formal charges. If you're not up to the point where you need to find the formal charge, then you can just chill with this diagram because it fills all the octets and you're chilling. But if you are up to the point where you're learning about formal charge and everything like that, then you should probably find that out, right? So we have oxygens. These oxygens have a -1 formal charge, right? How do we know this? We know this because these oxygens have a total of 7 valence electrons inside of their, like, that's how I imagine it, like their little circle. It's not counting this valence electron, it's only counting whatever's inside that little circle. So they have 7 valence electrons, but they normally have 6, which means they have 1 extra in their little circle. So each of these oxygens has -1, except this guy right at the bottom, right? Because this guy has 1, 2, 3, 4, 5, 6. This guy has 0. Hydrogen, 0. And then iodine. Iodine, how many does iodine have? We're going to count that up. So it's 1, 2, 3, 4. So he has 4 in his little circle, right? And it naturally has 7. So it's going to be +3. Now we can just add them all up. -1, -1, -1, +3. And that would be 0, right? Because the charge of HIO4 is 0. But we don't like that. They always want to minimize the formal charge. So let's try to do that. So how could we minimize the formal charge? We notice that the formal charge is more than or less than 0 on the oxygens. And in order to fix that, what we can do is we can try to move some of these valence electrons outside of away from the oxygen into the bonds, right? So we can take this one, we could put over there, and we'll do that for all of them. Because if we do that, we have oxygen's preferred state, right? We know that oxygen likes to make a double bond because it's easy for it. It wants 2 more valence electrons. So we're going to give all these oxygens double bonds. Generally, you can follow that trend, like nitrogen wants a triple bond, oxygen wants a double bond, chlorine wants a single bond, carbon wants what's it called? 4 bonds, but yeah, like 4 bonds. Quadruple bonds don't exist, by the way. Just saying. Or not to my knowledge that they exist. My limited knowledge. So we're going to be moving these valence electrons right over here. And now what do we have? So something you may notice is that the iodine has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 electrons, right? But we have to remember that the, what's it called? The formal charge being 0 matters more than the central atom having exactly an octet. So, and you're going to see that a lot with heavier atoms. You'll actually see that with noble gases. Noble gases will only bond if they're the central atom, and when they do bond, it'll be more than an octet. So let's continue, right? Now let's measure the charges. So oxygen here has inside of its little circles. Oxygen has 1, 2, 3, 4, 5, 6. 1, 2, so that's 0. Plus 0. 1, 2, 3, 4, 5, 6. Another 0. 1, 2, 3, 4, 5, 6. Another 0. And these guys already had zeros. And now we're going to count iodine, right? Iodine is a halogen. So it has normally 7 electrons. 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. So this works. Formal charge is cute. It's all zeros. It's great. So this will be the best version of HIO4. Thank you for watching. All right.